starting, we just put some black.
Oh, sounds good.
And QE2 is about 1.7 miles in size, and we know it's a safe distance away. It's about 3.6 million miles from the planet. And we have an image that you're looking at right now. It was taken yesterday from the South African Astronomical Observatory. So indeed, telescopes around the world are beginning to see it. We are right now in mission control to bring you a preview show of QE2 and give you some tips on how to see it for yourself and also answer some of your questions posted on social media. And this is all before closest approach, which occurs tomorrow, May 31st at 1:59 p.m. Pacific, 4:59 Eastern Time, and 20:59 UTC. Hello everyone, I'm Gay Hill. We'll be talking to folks at the South African Observatory in just a moment, but let's give you a little background on the asteroid. Protecting the planet is a NASA priority, and though this asteroid is not a threat, it is an excellent learning opportunity. NASA will be getting its best look at this asteroid ever using advanced and detailed radar. Let me introduce you right now to Paul Chodas. He's a scientist with NASA's Near-Earth Object Program Office based right here at JPL. The NEO program has already identified 95% of the asteroids that have orbits very close to Earth and are over 1 kilometer in diameter, which is about a half a mile in diameter. 1998 QE2 happens to be one of these that we're talking about. And Paul, why don't you just kind of brief us? Tell us a little bit about this particular asteroid.
Well, this is one of the big ones. So it's one of the 95% that we've characterized. It was discovered about 15 years ago, and it's one of the initial successes of our efforts to find the big asteroids that could hit the Earth and cause global catastrophe. So it's certainly one to keep an eye on. And we know it's passing at a comfortable distance.
And the name, why 1998 QE2? There's a formula to this, right?
Yes, it's not named after the ocean liner. It's not named after Queen Elizabeth II. It's a standard asteroid name. 1998 is the year it was discovered, and Q indicates the month, and E2, it was the previous one was D2, and the next one will be F2. It's just a standard designation.
All right, so you gave us an image yesterday to show us the orbit of QE2,
Yes.
and we can go to it right now and take a look
Yes.
at it. It's pretty large.
Yes, this is an eccentric orbit. You can see that it, right now it's right beside the Earth, very close, but at its farthest point from the Sun, it goes out to the outer asteroid belt, in fact, pretty close to the orbit of Jupiter. So it's an eccentric orbit. In a way, it's a visitor from deep space.
And you also gave us a graphic to show us the closest approach, to kind of give us an understanding of how far away it really is.
Just to put it in perspective, that's right.
And we have that image right
Here
here.
it is. Yes, you can see on the left is the Earth, and the ring around the Earth is the Moon's orbit for scale. You can see that the asteroid passes by, I put the dates on this diagram, it's about 15 times farther than the Moon is from the Earth. So it's a very comfortable distance, but for an asteroid this size, that's a close shave.
So this is one you would keep an eye on if it, for any reason, gets closer to us than the distance we have right here.
Exactly. We want to keep an eye on all of these asteroids, especially the large ones, and we don't know of any asteroids that have a significant chance of hitting the Earth right now, but we calculate the orbits for all of them and project them into the future.
So we're familiar with this particular asteroid. Do we know what it's made of? What are some of the characteristics? Things like that.
Yes, this asteroid is what we call a C-type, and we think that is associated with carbonaceous chondrite meteorites. So we have an example of a carbonaceous chondrite meteorite. It's very dark. The outer crust, of course, is black, as many meteorites are, but even the inside is very dark indeed. It's a very primitive type of meteorite formed in the outer solar system. It has amino acids in it, organic compounds, and a lot of carbon, which makes it dark. So it is a very dark object.
All right. So we have been briefed a little bit on QE2, and let's go ahead and speak to some folks who have actually seen it. QE2 was discovered 15 years ago in a survey using optical telescopes, and the South African Astronomical Observatory in Sutherland is a optical telescope. It's used for education and also research. And on the line right now is Nick Loring. She is one of the astronomers at that facility. Nick, what do you see? What did you see last night?
Hi there, Gay. Well, last night we saw the asteroid. So what we could see was a few background stars, which just looked like white specks of light, which weren't moving. And then we actually saw this white star that looked like a star moving across the field, just very, very slowly. And we knew immediately that was the asteroid because it was moving against the background of the stationary stars. So it just looked like a white dot. It actually looked like a star. It's just that we could tell it wasn't a star because it was moving relative to the background stars.
Was this difficult to find?
It was actually very easy to find because the asteroid's orbit has been mapped very well, and we actually used JPL's webpage to find the coordinates at a specific time, pointed the telescope at the coordinates, and there it was, right in the middle.
Well, that's Paul. Nick mentioned that she used JPL's website to help her with the coordinates. Could you talk a little bit about that?
Well, asteroids are observed by astronomers around the world, and all of the data is collected into a large set of observations, which we then use to calculate an orbit and run it into the future. And so we can predict where she should look to find this asteroid, and we know pretty accurately where it is. So if the predictions you get from our website on the orbital elements and where to look are quite accurate.
We're glad to hear that was helpful, Nick. And now, how are people reacting to this? Are they very enthused and excited?
Absolutely, yeah. People are really excited because I think it's just nice when you can actually see something with your own eyes. You know, when we talk about asteroids, we think of things far away in space that we can't see, and now all of a sudden they can actually watch the asteroid moving for themselves. So we've had quite a lot of interest on our Facebook and Twitter sites, and the press and media, and family and friends. You know, we're sharing the information on Facebook, and we're getting so many sort of comments, and people are really enthusiastic.
So, Nick, we have to explain to the audience, we really were planning to have a view of this live, but apparently weather is not good over there, I understand.
Yeah. Unfortunately, the weather is not playing along tonight. We had a lovely clear night yesterday. We got some really good footage. And tonight, unfortunately, we've been in and out of cloud. And just prior to the start of the program, it's really clouded up for us. So we've just been unlucky, unfortunately.
But that's how it goes. It's part of the territory, I understand.
Part of the package of being an astronomer is sitting up in a mountain in the freezing cold, under cloud.
All right. Well, thank you so much. That was Nick Loring. She is with the South African Astronomical Observatory in Sutherland, South Africa. Thank you very, very much for helping us out today. Well, for astronomers using optical telescopes, 1998 QE2 is faint, it's far away, it's not very exciting. But for radar astronomers, QE2 is outstanding. With radar, they have image resolution of about 12 feet on an object 3.6 million miles away. And by the time they're through with this observation, they'll have a better idea of QE2's orbit, its size, its shape, and even surface features.
1998 QE2 is going to make a relatively close approach to Earth on May 31st.
The orbit for this object is very well known. It'll be to the south, rising in the southeast, setting in the southwest. In late May, and especially early June, it'll reach a visual magnitude of about 10.5 to 11, and that means that amateur astronomers who have 4 or 6-inch telescopes could potentially see it.
It is going to come within 15 lunar distances.
About 15 times the distance between the Earth and the Moon. Although it is labeled as a potentially hazardous asteroid, what that really means is that its orbit can approach within a certain distance of the Earth's orbit. For the foreseeable future, there's nothing to worry about. I mean, it's far more dangerous to walk across the street.
The asteroid is believed to be about 1.7 miles in diameter. That is about 9 QE2 cruise ships end to end. It rotates with 5.3 hours, and we know it's likely rounded. Even the most powerful optical telescopes, and I'm talking even, Hubble telescope, they can only see this asteroid as a point of light. It is just too far and too small. Radar is a very powerful instrument that we use to study near-Earth asteroids. Asteroid Toutatis was millions of kilometers away, and we were able to resolve surface rocks. We could see boulders.
There are currently only 2 radar facilities in the world that have sufficient sensitivity for doing regular observations of near-Earth objects, Arecibo and Goldstone. It provides an extraordinary opportunity to get very detailed radar images.
You are transmitting microwaves. It's propagating at the speed of light toward the asteroid. It is bouncing back. And this radar echo is containing surface features of the asteroid. It's telling us about its rotation, and it's very precisely pinpointing its distance from the radar. This is a great opportunity because instead of sending a spacecraft to an asteroid, you are on Earth, and an asteroid is coming to you.
We think we're going to see images that will rival the caliber of what we can get from a spacecraft flyby mission. They really should be that detailed. And opportunities like that, they sometimes happen a few times a year, but this is the best one that we know of in 2013.
And last night, Goldstone's 70-meter antenna, also known as DSS-14, was moved into position and pointed at asteroid 1998 QE2. And as we heard, it's one of 2 telescopes in the world that are large enough and with transmitters powerful enough to observe asteroids. So last night, DSS-14 sent out a radar signal from the antenna. The energy bounced off the asteroid and was received by the same antenna and then processed into images. Images like these. They don't look like pictures on your regular digital camera. They're more like ultrasound images. The principles are quite similar. They don't look like regular pictures, but you can still see things and recognize things. Right now, radar scientist Marina Brozovic is part of that observation team, and she is at Goldstone right now. She was observing last night to give us the results. Hi, Marina.
Hi, how are you?
So how did it go last night?
Well, it was quite a bit of surprise. So it turns out that 1998 QE2 is a binary asteroid.
Big surprise.
And this is something that we did not expect. Especially, I was looking at this earlier footage, and we have to make some revisions to that period of rotation. So initially, we thought that it's rotating with a period of 5.3 hours because that was what was reported to us by the optical observers and based on the light curves. But for such a type of rotation, we really don't expect to see any satellites. And this one turned out to be rotating probably much more rapidly, probably less than 4 hours. And the first thing we see, there's this object, and it has a satellite.
Well, we have the still pictures that we can show folks, and you can see the different frames and a very light, small object in front of it.
Yes, so what you can see here, this the larger object on the screen, that is the primary. That is the primary, and then this little bright speck of light over here in the back, that is the satellite. And the satellite is in its orbit around its primary, like the moon would go around the Earth. So what you're seeing over here, these are radar images. They're different than optical images. And each frame is a snippet about 10 minutes of data, and you can clearly see that both the primary, these kind of features on the primary, this kind of radar dark spot, is rotating. It's rotating as this time sequence is progressing, and at the same time, what you're seeing is that the satellite is moving more toward the back, so it's moving away from the asteroid.
Now, where this is really evident is when you put it into a movie form, and we can show folks that right now. There you see it.
Yeah, you can clearly see. You can see the evidence of the rotation of the primary because this is, I have to say that resolution of these images is 75 meters per pixel. So we still haven't reached our highest possible resolution because the object is still a little bit far away. But even at the 75-meter resolution, what we can see is there are clearly some radar dark features, some concavities maybe. Maybe those are, in fact, craters or something, but we can't know this for sure. And we definitely can see that there is a satellite. We estimate the size of the primary was right on. So it's about 2.7 kilometer in diameter, and the satellite is about 600 meters in diameter. So this satellite appears to be small on the radar image, but it's not. This is kind of this different dimension on horizontal.